Now we're going to take a look at another problem that we'll solve using vectors. I'm going to bring this board in. I'm going to prop up one edge. So now I have a ramp. And I have a car here, and this car rolls very freely. Well, if I take this car and I drop it, it's in free fall. And we know it falls with an acceleration of 9.8 meters per second squared. You know this, that's just free fall. How if I take this car and I put it on the ramp and I let it go? In this case, it accelerates, but not down. It accelerates down the ramp. Here's a question. When I let this go, what can you say about the magnitude of the acceleration along the ramp? We're going to define an axis that moves along the ramp. Along that axis, what can you say about the acceleration? We'll give you some choices. And in fact, this is a problem that we can solve with vectors. And in this case, we'll take components of vectors. We'll think about this. We know that if I drop this car, there's an acceleration, it's free fall, and it's directed downward. So the free fall acceleration is a vector that's directed downward. But now, when I put it on the board, we can take that free fall acceleration and break it into two components. There's the component which goes perpendicular to the board, and that component is blocked. But there's also a component of the vector that points parallel to the board, and that component is the component that causes the acceleration of the car. So when I let it go, it'll experience an acceleration down the board, but it's only a component of the free fall acceleration. And so the acceleration will be less than 9.8 meters per second squared. And in fact, you probably would have guessed this just from your sense as to how the world works.